So today we're diving into one of the biggest, most frustrating challenges in modern cancer treatment. We're talking about what happens when our very best drugs just stop working. But we're also going to look at a fascinating new study that might have found a way to take on a tumor's secret weapon. Let's get right into it.
You know, this is the heartbreaking question that drives so much cancer research. You have these revolutionary drugs that give so many people new hope, only to see the cancer somehow outsmart the treatment and come roaring back. So to really understand the potential new solution, we first have to get a handle on the problem.
And that problem really starts with one of the greatest breakthroughs we've ever seen in oncology, a type of treatment called immunotherapy.
The whole idea behind immunotherapy is just, well, it's brilliant. Instead of attacking cancer with something like chemotherapy, the goal is to take the brakes off your body's own immune system, basically empowering it to hunt down and kill cancer cells all by itself. And drugs that do this, called checkpoint inhibitors, they've been an absolute game changer for so many patients.
But here's the reality check. While it's been a true miracle for some, for a whole lot of other people, immunotherapy hits a wall. A big chunk of patients just don't respond right from the start. And even for those who do get a good response, many of them eventually watch their cancers evolve, develop resistance, and start to grow again. So you have to ask, why? Why does this wall even exist?
Okay, so this is where the detective work really begins. Researchers have been on the hunt for the specific tricks tumors use to hide from our immune system. And it turns out some tumors hire a very, very effective bodyguard.
Meet GDF-15. It's a protein that some tumors just churn out in huge quantities. And you can think of it exactly like a bodyguard. Its entire job is to stand guard, create this invisible shield, and basically tell your body's immune system, nope, you're not welcome here. You can't come in.
And what's so wild is how simple and yet how incredibly effective this strategy is for the tumor. It just pumps out GDF-15. This protein then sets up a kind of biological force field, and this shield literally stops our immune system soldiers, our T cells, from getting inside the tumor to do their job. The army is right there, ready to fight, but it just can't get past the gate.
So if the whole problem is this bodyguard, then the solution seems kind of obvious, right? You've got to neutralize that bodyguard. And that is the really clever strategy behind a new clinical trial, which, by the way, is a fantastic name, the GDFR trial.
The plan here was a classic 1-2 punch. First, they bring in a new drug called visugramab. Its one and only job is to find and neutralize that GDF-15 bodyguard, essentially tearing down the tumor's shield. Then, they come in with nivolumab, a veteran immunotherapy drug which is there to hit the go button on the T cells, telling them, okay, the coast is clear, go attack.
And listen, this part is absolutely crucial for understanding why these results are so striking. The GZ-Tofather trial, it didn't enroll the easy cases. No, they specifically chose patients whose cancers had already outsmarted and become resistant to standard immunotherapy. These were people who were really running out of options, which makes the stakes here just incredibly high.
So you've got this clever two-drug takedown strategy, and you're testing it in a group of patients with very few options left. So the big question is, did it actually work?
Okay, before I show you the results, we really need to set the bar here. For this exact group of patients, if you just gave them the same old immunotherapy again, the chance of it working is 5%, or even less. That is a very low bar. So anything, and I mean anything, significantly better than that would be a huge deal.
And the results, well, they were dramatic. The response rate was not 5%. In certain cancers, like non-squamous, non-small cell lung cancer, it was 19%. That is a nearly four-fold increase over what anyone expected. In the world of oncology, for this group of patients, that is a really meaningful and incredibly exciting result. But it wasn't just a number on a chart. The scientists actually went in, they took biopsies of the tumors to see what was happening at a biological level. And they found exactly what they were hoping to see. The shield was down. More T cells were flooding into the tumor, they were multiplying, and they were armed and ready to kill cancer cells. The strategy was working exactly as they designed it.
And it gets even better. These responses weren't just flashes in the pan, they were durable. The average time patients stayed in response was over 15 months. Some people even had a complete response. Their cancer totally disappeared, and they're still cancer-free over 20 months later. And, what's really important, this two-drug combo was generally safe and well-tolerated. So look, these are incredibly promising results, right? But what does it all mean for the future? What's the road ahead for this new strategy?
Now, we have to be clear-eyed about this. It's still early days. It's really important to have a balanced view. The strengths? They're obvious. It works in a super-resistant population. There's strong proof that the science is right, and the responses are deep and they last. But we also have to be realistic. This was a pretty small, early-stage study, and we're still waiting to see that long-term survival data.
So the to-do list for researchers is pretty clear. They need to run much larger, randomized trials to really confirm these findings. They're also going to work on developing tests to better predict which patients have this GDF-15 bodyguard and are most likely to benefit. And of course, they'll want to explore using this strategy in other tough cancers, like pancreatic cancer, and maybe even in earlier stages of the disease.
Look, this study is just the first step on a long road, but it really opens up this tantalizing possibility. It leaves us with this huge question. We have these revolutionary immunotherapy drugs that have already changed the world. Could taking out the tumor's bodyguard be the missing piece of the puzzle that finally unlocks their full power for so many more people? Only time will tell.